Hey guys, so I am going to go through some notes and some practice problems that will help you on the assignment mass to mass. And what we are going to be doing today is we're going to be using mole ratios like we did yesterday to calculate the mass of a product or of a reactant. Okay, so before we get started in that though, I have a just kind of like analogy that I wanted to share with you guys. Okay, so let's pretend that I have 12 cotton balls. Okay, I have 12 cotton balls, and I also have 12 bowling balls. Okay, if I have 12 of these and 12 of these, that means that I have 12 of each. Okay, so each cotton ball is equal to one bowling ball because it's a 1-to-1 ratio. Okay, but if I wanted to say one cotton ball weighs the same as one bowling ball, that would not be true, because even though it's a 1-to-1 ratio, the things that I have weigh very different amounts. Okay, so it is not a complete 1-to-1 thing. I can't just say 12 cotton balls equals 12 bowling balls. One cotton ball is the same weight as one bowling ball. Okay, so that's kind of what we're doing today, where if I have one hydrogen, it may be proportional to one nitrogen in the equation, but that does not mean that they weigh the same, because nitrogen is a much bigger, heavier, massier thing. Okay, so that is kind of what we are doing today. These problems are going to be 3 steps. Okay, and so I'm going to go ahead and just write out our steps here. So step 1 is always going to be go from grams to moles. Okay, then we have step 2, which is going to be going to moles, which is exactly what we did yesterday. Sorry about that jump, I had a kid walk in. Okay, so moles to moles, and then we have step 3, which is going to be going from moles back to grams. Okay, so this is what we did yesterday, and these are what we did in the last unit. Okay, so we're combining last unit with this unit. All right, so let's get a problem and figure out how we're going to do this. All right, so let's say we have 35 grams of aluminum, and I'm looking for how many grams of AlI3. Okay, so there's my problem, and then my unbalanced equation is going to be Al plus I2 yields AlI3. Okay, now remember, this is an unbalanced equation, so before I can even go into the new stuff, I have to balance this. Okay, so I'm going to draw my arrow. I have Al and I have I. Over here I have 1, and I have 2 of those. Over here I have 1, and I have 3. Okay, so 3 is an odd number. That's going to be really hard to balance. The best way to do that is to double it. So I'm going to put a 2 here, make that a 6, and that's a little easier for me to balance with. And then I also have 2 aluminums now. Okay, so if I go back over here, I need to make 2 aluminums on this side. So I'm going to stick a 2 there, which gives me 2. And I need to make 6 aluminums over here. So I'm going to put a 3 there, and now my equation is balanced. Okay, so this is my conversion factor. All right, so in order to figure out how many grams of aluminum makes grams of this aluminum iodine compound, I have to first go from grams of aluminum to moles of aluminum. Okay, so I'm going to draw my T-chart, and this is going to be a long T-chart. Okay, I'm going to start up here with the thing that I know. And I know from my problem that I have 35 grams of aluminum. Okay, now I need to go to moles of aluminum. So if I have grams of aluminum here, I have to have grams of aluminum down here. Okay, now my problem does not give me grams of aluminum. So in order to figure out grams of aluminum, I got to go to my periodic table, where I can see that aluminum is 26.98 grams. So 26.98 grams of aluminum is how much aluminum is in 1 mole of aluminum. Okay, So grams of aluminum cancel each other out, and I'm left with moles of aluminum. Now, I'm not looking for moles of aluminum. I'm looking for grams of ALI3. Okay, so I need to get rid of moles of aluminum. So I'm going to get rid of moles of aluminum by putting moles of aluminum down here. Now I'm trying to get to ALI3. Okay, and since I'm in moles, I can use this conversion factor that I found. Okay, so I know that for every 2 moles of Al, I have 2 moles of ALI3. Okay, which gets rid of moles of aluminum, and I'm left with moles of ALI3. But I'm not looking for moles of ALI3. I'm looking for grams of ALI3. So I know from my periodic table that 1 mole of ALI3, it's not an element, but I can't find it on here. So it's going to be aluminum, which is the 26.98, and 3 iodines, which is 126.90. And that's how many grams are in 1 mole of ALI3. Okay, which, if I do some math, that ends up being 407.68 grams of aluminum. Okay, so that gets rid of moles of aluminum, and I'm left with grams of ALI3, which is what I was looking for. Okay, so then it is just simply plugging this all into the calculator. So I've got 35 times 1, which I'm not going to do, times 2 times 407.68, and then I'm going to hit equals, divided by 26.98 equals divided by 2. Gives me 528.9 grams of ALI3. That's my answer. Okay, so let's do another one because these are a little bit more complicated. They add in everything that we did in the last unit combined with what we just learned yesterday. So let's do another one, okay? So if I have H2O2 gives me some H2O and some O2. And my question is going to say, how many grams of H2O2 does it take to react or to make 24 grams of O2? Okay, so before I can even get into the new stuff, I have to make sure this equation is balanced. Okay, so I'm going to balance it real quick. I've got some H's and I've got some O's. All right, over here I have 2 H's and I have 2 O's. Over here I have 2 H's and I got 3 O's. Okay, so this 3 is a concern for us. I don't like him. It's hard to balance an odd number, so I'm going to try to make him an even number. Okay, so I have 2 O's here. I want to make there be an even number of O's here, so I'm just going to stick a 2 in front. And that now gives me 4 oxygens, which is an even number, and that's a lot easier to balance. Okay, it also changes my hydrogens, so I have 4 of those now. Okay, so now if I go back over here, I have 2 of each. I need 4 of each. I'm just going to stick a 2 in front, and now I'm balanced. Okay, so this is my balanced equation that I'm going to use. Okay, now I want to know how many grams of this it takes to make 24 grams of that. Okay, and this is my mole ratio. So I'm going to start with the thing that I know, which is I have 24 grams of O2. Oops, I'm looking for that. I have this, I'm looking for that. I'm not messing with that. So I have 24 grams of O2. Okay, I'm looking for grams of H2O2. Okay, so I need to get rid of grams of O2. Now here's where it gets a little bit annoying, because if I look at my periodic table, I can see that oxygen is 16 grams. But I don't just have 1 oxygen here, I have 2. So if I have grams of O2 here, I need to have grams of O2 down here. And since there are 2 oxygens, there are 32 grams in 2 oxygens, because oxygen is 16. So 16 plus 16 is 32. Okay, so I know that that is how much is in 1 mole of O2. Okay, so my grams of oxygen I cancel, and I'm left with moles of O2. Okay, I'm not trying to find moles of O2. I'm trying to find grams of H2O2. So now I need to switch over into H2O2. Okay, so if I have moles of oxygen here, I got to have moles of oxygen here. And I know from my balanced equation that I have 1 mole of O2 is 2 moles of H2O2. Okay, so that gets rid of moles of O2. Now I'm left with 2 moles of H2O2. I'm getting closer. I'm trying to get to grams of H2O2. Okay, so I'm going to use my periodic table to figure out that 1 mole of H2O2 is equal to 2 H's, which is 1.01 plus 1.01, so H2O2. So my total mass is 34.02 grams is equal to 1 mole of H2O2. So my moles cancel, and I'm left with grams of H2O2, which is what I'm trying to get to. So I'm going to stick an equal sign on that. Okay. Then I'm going to start plugging it into my calculator, where I've got 24 times 2 times 34.02 equals, divided by 32 equals, divided by 1 divided by 1, 51.03 grams of H2O2. Okay, so for the purposes of this assignment, you just need to make sure that you keep these steps in mind. So first you balance, then you go from grams to moles, then you go from moles to moles, then you go from moles back to grams. Okay, so it's kind of annoying because we're kind of having to translate between lots of different units, but all of the problems are going to be 3-step problems. So they're all going to look like this. Okay, you're always going to go from grams to moles, moles to moles, and then back to grams. Okay, so that is how you do the mass to mass assignment. Please let us know if you have any questions, and yeah, thanks guys, bye.